Hey everyone, welcome to this week's Inside.net. My name is Cecil Phillip. I'm joined with my host, Rodney Little II. Rodney is down
Oh,
here. There we go.
you're up
And
there.
today, really excited about today's conversation. We got Steve here from Redis Labs specifically. And he's
It's
going to
actually
talk.
it's just Redis now. We
Oh, it's just
rebranded
Redis?
2 years ago.
Oh,
It's
was
just
it
Redis.
Redis Labs Inc. before?
It was simply Redis now. Just Redis.
Okay.
Just
Well, here's
Redis.
Steve's here from Simply Redis.
Simply Redis.
And he's going to talk to us about a topic I think a lot of us as developers, as .NET developers, are probably curious about or even have a little bit of experience with, and that is using Redis. But I think we want to go a little bit deeper today. We want to talk about more about Redis's capabilities other than key value. We want to dive a little bit deeper into some of the additional use cases and capabilities of the tool. So that's kind of what the goal is today. But before we do that, Steve, why don't you really quick give folks a little bit of an introduction, let them know who you are and what do you do.
Sure. My name is Steve Lorello. I am a senior field engineer at Redis. So what that means is I work on different integrations and things that help our customers be successful with Redis and members of the community be successful with Redis. Before this, and what makes this a pretty pertinent topic for me, is that I was the .NET developer advocate for Redis. In that time, I built RU102N, which I think Cecil's going to highlight later, which is the .NET course for Redis developers. I also built RedisOhm.net, which is essentially a link-based interface for Redis. So I've been a .NET developer for more or less my entire career in software development, spanning back like 8-ish years now, I want to say. So I've been around the block a lot, and yeah, I know basically what there is to know about .NET and Redis. So yeah, hey, nice to meet you all.
Awesome. Well, Steve, we're really glad that you're here. Like I said, I feel like I've been hearing about Redis, and I've used Redis from I can't even say I've used it from a level of abstraction so high above that I have never really even had to touch it. You know what I mean? I've just had to like point to a connection string, and then the frameworks just do what they need to do. So I personally have never had to like use the CLI or even look and see what the contents of the data structures are. It's just been like, oh, okay, set up your connection string and run, right? I'm like, okay, great, I can do that. Like that's easy. But again, like I said, like I'm hoping what we'll do today, we'll go a little bit deeper and like dive into like the guts of Redis a little bit and just kind of talk about it.
Sure. Well, like the two features that people really like about Redis is that it is super easy to get up and running with.
Yeah.
And it's super fast.
Yes.
So those are the two big things that kind of draw people into Redis. And you're talking like the CLI and like the command-based interface is basically what there is to like sort of just that's all you need to know to get up and running with Redis and working with Redis. And yeah, you're usually as a web developer, you're usually probably interacting with Redis from a layer of abstraction through like if you're a .NET developer, presumably a .NET developer through like the iDistributed cache or one of the old caching frameworks in the .NET framework.
Yeah, exactly. But before we get super deep into the conversation, I'm going to switch over and bring my screen up because today is the time for the highlights. Let's go through some of these highlights that have been happening within our community. Now, Rodney and I are big fans of RX.net, reactive extensions for .NET. And recently, just last week, Ian Griffiths, he published this blog post about RX 6.0 that's now available. I think it's available in preview, but it's available now. So a lot of great updates in here, support for trimming, tons of updates and things of that nature, support for modern versions of .NET. So if you are a RX fan, I'm sure you'd be happy to see this. Make sure you head over to the Engine, ENDJIN, Engine blog, and you can learn a little bit more about it. Also, too, really quick shameless plug. Like next week on the JetBrains ReSharper/.NET webinars that they do, hosted by our friend Khaled. I'm going to be talking about how you can build payment workflows with Stripe and Azure. So what does that mean? So we're going to be talking a little bit about Stripe, but we're also going to be talking about webhooks. We're going to be talking about persistent workflows using Azure functions and durable functions. We're going to be talking about like pause and resume and like all these fun types of things that you might want when you want to have like a reliable payment system. So that should be fun. Again, make sure you check that out over with the JetBrains folks. Yesterday, very fitting, yesterday, the folks over at Microsoft Developer published this video, and it's called Zoom, right? Introduction to Azure Redis. Really short video, not very heavy on the code, but it does talk on a very high level about like what are some of the things that you could do, how you can set it up, the different tiers and things of that nature of running Redis on the Azure Redis service. So again, if you're interested, make sure you head over to the Microsoft Developer YouTube account, and then you can check that out. And last but not least, Steve was just talking about this a little while ago. So the Redis for .NET Developers course on Redis University, you can head over here to university.redis.com and look it up. And it looks like it's already started, but I'm sure you could still sign up for it and jump into it, right, Steve?
Yeah. So the way this works is like we run 6-week cohorts of the courses, and you can always sign up and take the course. Just later on in the course that you start, you might have a slightly more condensed schedule, which you could finish it, but it's still very manageable in whatever time you end up getting it. It's maybe 10 hours of actual work if you're going through everything. Yeah, it's a really manageable course. And I mean, this is sort of a shameless plug for me because I wrote the course, but it'll give you really the total overview of Redis you need as a .NET developer as you're trying to get involved and learn about the database and using it from .NET.
Okay.
Right. And if I kind of zoom in here a little bit, so if the folks are wondering what will you learn in this course, so you talk about setting up testing environments, going through these different data structures, lists, strings, sets, sorted sets, hashes, streams, writing scripts. I'm guessing scripts means Lua. I'm guessing there's some Lua.
But hey, no, I shouldn't say anything. But there might be more than just Lua coming soon. I mean, we have Redis Gears, which is its own thing, which has Java and Python scripts that you can run. But that's a whole other thing. That's a whole.
Got it.
I
will say I like the fact that the first thing on the list is setting up a test environment because that's important when you're dealing with caching. Just saying.
Well, it's important to be able to run your code, whatever you're doing, right? That's
gotta exercise it.
Yep.
Cool. All right. Well, I'm going to take my screen off, and Steve, why don't we kind of just dive into our conversation and talk about Redis?
Sure.
Now, I like a good person, I went and did some research. And I learned Redis stands for, oh my gosh, I'm going to get this wrong. Does it Remote Dictionary Server? Is that correct? Is that what it stands for?
That is exactly what it stands for. Yes, it's an acronym that stands for Remote Dictionary Server.
Remote Dictionary Server. So when I think about dictionaries, and I think about dictionaries from a software developer perspective, I think I have a key and I have a value, right? And I have a collection of the keys and values, right? So is Redis really, from its grassroots definition, is it really just that simple? Is it just a place where I could put stuff in and pull stuff back out?
Yeah. So fundamentally, what Redis is, it's a key value data structure store. So it's a key value store. It is a key value database. It is probably the most. I don't want to say it's the most heavily used, but I think it might be the most heavily used non-SQL based database in the ecosystem.
It's definitely up there.
I don't want to say it definitively is. I think it's the most beloved. If you look at like the Stack Overflow survey, like the two most beloved databases out there are Postgres and Redis, and we sort of trade off with each other. Postgres want to beat us out last year, but we're all good with that. But Redis is super beloved, and it's very popular and very heavily used in the community. Mm-hmm. It's a non-SQL based key value data structure store. It's fundamentally what it is.
Okay. So let me ask a question, right? Because I want to get into semantics. So you are explicitly saying key value data structure store, right? Mm-hmm. Which is to be completely different than a key value document store, right?
Yeah.
So I'm going to come back to that nuance later because I deal with document databases being a mobile developer and dealing with a lot of so I've dealt with a couple and I've used Redis, but I've never used it as a document database, but someone suggested it as such a couple of months ago. And I was like, I don't think it's supposed to do that, but I think it can.
You can, sure.
Right.
Sure. Document uses a document database is something that people do use Redis as. People do use Redis as their primary database.
Nice.
And they do it because it is extremely fast. And with some of the indexing inquiring capabilities that we at Redis have added to Redis over the last half decade, 7 years, makes it much more possible to do that.
Nice.
And makes it much more feasible to do that. And we can talk about actually storing like JSON documents in Redis and indexing them and querying them a little bit later if you want to.
Yeah.
So I want to piggyback off of what Rodney just said, but just from a different angle. So I have been a part of a lot of heated discussions that question the definition of a database.
Yes.
Right? So for me, a database is just a place that you put information. You put it in and you get it out. And for me, it's that simple, right? A file could be a database, right?
Yeah.
Depending on how you use it. Now,
The most popular NoSQL database in the world is in fact Excel.
There you go. I've gotten into these conversations around because I think maybe, and let me know if I'm wrong, but in the earlier days of Redis, it was primarily in memory. So like this in-memory data store, the question was, is this a caching service or is this a database, right? And so I would love, and I kind of feel like I know what you're going to say because you work for the company, but
that's a great question.
On it being just a thing for caching data in memory with really fast response times to is this is this a database by the the standard definition of the term database?
Yeah, so like the totally in memory thing is both accurate and slightly misleading. So in reality, the entirety of a Redis database is preserved in memory at any one time. So the whole thing is always in memory.
Okay.
There's this thing called Redis on Flash, which allows you to extend the memory onto your flash disk and basically use virtual memory. That makes it more economical to store more stuff in Redis. But Redis is fundamentally a in-memory database. What I like to say though, and actually this comes from a colleague of mine called name is Guy Royce, who's a developer advocate at Redis. He likes to call it a memory first database, which is really what it is, because Redis can and does persist to the disk based off of how you configure it. So if you go off the baseline configuration, it doesn't actually store anything to your database to your disk, but you can, and most people do, configure it to use one of two persistence layers. There's two persistence layers. The first one is the RDB file, which is just like you're taking periodic snapshots of the database.
Mm-hmm.
So like every couple of minutes, if there's been X number of writes to the database, you'll take a snapshot of the database and save that data onto your disk. And then when you want to reload Redis, you can just take that RDB file and suck all the data back in and have your whole Redis database restored. The other thing that people do, which is also very common, is there is a AOF file. AOF stands for append-only file. And what Redis, the way that Redis operates, it just runs its you run commands against it, like so set foo bar, hset hash, name Steve, age 35, 34, however old I am now, yada yada yada, and basically all of those write commands are committed to this append only file. So and when Redis starts back up, if you use this append only file, you point to that append only file and it basically goes through and just runs all the commands to get you back to the original state. Now you can actually compact that file so it only has the last setting of each key in there. But basically what these two things do is they pull in, they allow you to persist Redis to your disk so that it's not just a totally volatile cache, right? So that's the big concern. It's like, oh, it's all in memory. So if Redis dies, then I just lost all my data. And that just isn't true if you're configuring Redis for persistence.
So you said something, and it's interesting. a memory first database, right? So we Cecil and I talk about reactive extensions and IEnumerable and IObservable, right? So like I go to a SQL database, I pull something out of persistent storage and bring it into memory. And it sounds more like Redis is like I'm really actually memory first, and I just dump to a disk when I'm supposed to, so that I can reboot myself.
Yeah, if Redis dies, you can reboot off the disk.
Right. So really, I am I'm really the last in memory representation of your state.
Exactly.
At any given time. So I like that approach because it gives me an alternative, right? Like we always talk about when we're building new software and we're looking at a technology, we shouldn't just go use the thing that we're comfortable using. We should use the thing that solves a problem. And it sounds like Redis solves a completely different problem being a memory first database than a SQL database could ever solve.
Yeah, so what Redis does is it allows all of your data that you have interest in accessing to be available all the time in memory. And the other thing is that's the way that Redis the Redis data structures are constructed. They encourage you to only access things in ways that are efficient, or almost always only access things in ways that are time efficient, right? So like the basic sets and gets of Redis. You're setting a key and getting a key. That's an O1 lookup, right? If you're using a field and a hash, and you're just pulling out of a field out of a hash, that's 2 O1 lookups to grab it. If you're looking something up in a set or a sorted set, like those are log n lookups. If you're using a list, yeah, that's in order n because it's a linked list. But like all of these data structures are essentially constructed to allow you to have efficient access to what the data that you're looking for is, and because it's all in memory, you never have to jump to the disk to actually read it off the disk.
Right.
Everything disk related is performed on a background thread and is write only, right? So you're only writing to the disk. You're never reading from it unless you're in the initial boot up phase of Redis. Now, I said that it's always on a background thread that happens. That's not entirely true because you can tell it to do it synchronously and to synchronously flush everything out to the disk. People usually don't do that because it kind of defeats the purpose of having an in-memory database or like a totally in-memory database and a memory first database, but it's something you can do. But generally, if you're persisting stuff to the disk, you're doing it in the background, it's write only, and it's taking up clock cycles on your CPU to actually write the stuff out. But in general, like your data is hot in memory and accessible by whatever these data structures are, whatever data structure you're using, and usually it's a very low latency access because you have thought about your data model and you have ready access to the things that you're looking for. Make sense?
Yeah. Oh yeah. So you keep using the term data structure. I like picking apart semantics, right? So like you keep using the term data structure. So am I led to believe that Redis kind of not forces you, but encourages you to do things in a way that's good for Redis based upon a set of actual objects that you provide? Or is it what convention is Redis using to kind of force me to be a good developer as it is?
Well, so here's the thing. There's a bunch of data structures that exist in Redis. The basic one is a string, right? Okay. So that's your set and get.
Right. Okay.
Set and get, you're just setting and getting a string.
Right.
There's hashes, which are dictionaries. So like, Redis becomes a dictionary of dictionaries.
Right.
Right.
Yeah. Why not?
There's sets, which are unordered sets, so like a hash set.
Okay.
There's sorted sets, which are sets, but every string in them actually has a value associated with them, so you can sort them.
Right.
There's streams, which are basically a message queue. There is, if you get into the other data structures of Redis, off of like that we built for the community and for Redis Enterprise, we have JSON, which allows you to actually store JSON in Redis and access it via their JSON path. There's all the stuff around Redis Bloom, which is a bunch of probabilistic data structures, which is a whole awesome and interesting talk and discussion in of itself, but basically allows you to use very memory efficient and very fast ways of answering questions like, oh, have I encountered this object already? Oh, how many times have I encountered this object? Those kinds of things. what's the median or this quantile of the samples that I've seen? We have a time series database that you can use that basically you're just inserting values and timestamps in, and it allows you to compact those things together and pull them back out. Yeah. There's all sorts of different things. But to answer your question though, like we have these data structures so that you can pick the right data structure for what you're looking to accomplish with Redis.
Right. So it's so what you're telling me is it is not just a string key value store, right? I have a string key and I have some string value and I stash it in Redis, and that's the limit of its capability. You're telling me Redis can provide an actual in-memory database with data structures that will help you, that are optimized to go against Redis. That's completely different than the uses that I've had of Redis and my knowledge of the software. So like this is
Redis is basically network memory. It's all the data structures that you learned about in college, in behind a TCP protocol.
Got it.
And a command level interface. That's what it is.
Got it.
And like the beautiful thing about the community is that the community has been able to grow up in this way that different people from the community have their own takes of how they want to interface with Redis, and they build the integrations around it, and it's just really cool what's happened with the Redis community with all the different client libraries and all the different ways that people have found to use Redis.
So we got one question that I want to pull up. This one's coming in from LinkedIn, and she's asking, I have a question. Redis as a Alexa, stop. I'm sorry. I don't know why. As a primary data store in memory, does it make two lost in case of system crash? So I guess this is kind of like the question you were asking a little bit earlier, right? Like if it's in memory and it shuts down, like what happens? And like you said, I think what you told us before was by default, it doesn't really write to this, but it can be configured to do so. And then you can set up the necessary intervals and strategy or whatever the case is. And I'm guessing also too, if you have a cluster of Redis servers all communicating with each other too, like I'm sure there's strategies around like how that data syncs and is persistent on each node or
shard,
cluster, right?
Yeah, each shard. So this is the question that everyone has about this memory first database. It's what happens if Redis dies? Like, do I lose all my data? Because that doesn't sound like it's a particularly durable solution for my primary database. And the answer to that is like mostly not, because most people, if they're looking to use it for a persistence layer of any kind, they configure either the AOF or the snapshot. People usually configure the AOF, which is that append only file, because that keeps a more live record of what's going on in Redis. Yeah. And there's 3 settings for the AOF file. So what the AOF does is every time you get a write command, it writes that command to a buffer, and that buffer is being written to the disk. And there's a separate policy that tells it how frequently to flush that buffer to the disk. This is called the fsync policy. That fsync policy there's 3 different settings. There's 1 sec, which is the default. So every second, that write command is actually flushed to the disk. So the largest amount of data loss that you're subject to have in that 1 sec policy is you could have 1 second of data loss. It's
1 second of data loss, right?
Possible. And it's realistically, this is something you're going to have to contend with on any distributed system, right? There's always, which always you're flushing it to the disk. So with every write command, you're then going and you're writing it to the disk. I mean, people do this, but and that gives you perfect durability, because anything that interacts with that Redis data store is being persisted to the disk. So you know that that's happening.
Right.
But also all of your write commands become disk bound. So people don't usually do that. Right. And then there's no, which doesn't mean that it's not writing to the disk. All that means is that buffer is being flushed when the operating system decides it's going to be flushed. So that leaves it up to the OS to decide, I see this buffer hasn't been flushed in 2 seconds. Let me flush it. And that's a little bit more like you don't necessarily care if it's exactly 1 second or never gets or gets flushed every time, but a little bit more laissez-faire about it, right? But yeah, so like realistically, if you want to have durability in your Redis data in Redis, you're going to set up AOF and you're going to have it with some sensible setting, and that's going to be. It does require more CPU if you do that because it's got to do IO operations right to the disk in the background. But that's the neat thing is that you can actually configure. You can configure all of this.
Got it. All right. Well, we'll see. Let's do this. Why don't we switch over to your screen? And I'd love to see. Let's play around with it. Right? Like, let's see, like, what it actually looks like to go beyond like key value stores in Redis.
Yeah.
Okay. So your screen now, and great. So we got your screen. We got your desktop up.
Yeah, this is my desktop. So let me just pull up WSL real quick. Let's. Hold on. Why am I? There we go. Sorry, I'm used. Because I knew this was a .NET talk or this was a .NET conversation. I figured I would use Windows because it would freak people out if I used my Mac, and also, the way my desktop is set up, it's easier to use my Windows machine. So the first thing I'm going to do is, I'm going to check Docker real quick. So I'm just going to kill that real quick.
And it's funny you say that too, because I don't think I've ever been on this stream on a Windows machine. I've only ever used.
Oh, really? Well, since .NET Core, so many .NET developers have moved over to Mac.
Yeah.
And do you have like an old Intel Mac or do you have an M1?
I have both.
What'd you say?
I have both. We both have both.
We both have both.
I have both too, and the M1 just totally blows the Intel one out of the water. It's crazy.
It is.
It's nuts how much better it is. It's so much better than any Windows or not Windows. Any Windows laptop I've ever used before. So the first thing we're going to do is we're going to start Redis, and the first thing I should say is there's many ways to start Redis. I have Redis installed in Ubuntu on this machine. I have Redis Stack installed in Ubuntu on this machine. You could run it in AWS. You could run it in Azure. You can run it in GCP. You can run it wherever. But the easiest way for me to show you how to use Redis is just to do Docker run and point to 6379, which is the normal port for Redis, and just run Redis. And you're off and running. You have Redis running. So the next thing I'm going to do is I'm going to just pop open the CLI real quick, and we will get to .NET code, don't worry. And I'm just going to show you a couple of things in Redis. So the first thing to do is to check what version of Redis am I in. So I can do an info server. And you can see that it'll actually pull up, and I'm on Redis 7.0.4. We're working towards Redis 7.2. That release is going to be coming out eventually. I think the release candidate for it just came out a couple of months ago, so we're going to get there eventually. And then, like I said, there's different data structures in Redis. So the first and most generic one is the string. So I can do set foo bar, and then I can get foo, and you can see that bar is in here. I could then say if I want to set an expiration on foo, I can expire foo in 5 seconds, and then I can do TTL on foo and see that it has 2 seconds left, and it keeps counting down, and then eventually goes away. So if I get foo again, it's gone. But that's the string. Like the string
is expired, and is there negative one and then a 0? Like are those numbers different?
So -2 means it's expired.
Okay.
Right. The key used to exist, right? The key you asked for used to exist 2 seconds ago, but it doesn't exist now.
But no, the -2 just means the key doesn't exist anymore.
Oh, okay. Well, yeah.
So if I
like
TTL
value then.
Yeah.
Okay.
So and if I get nothing, I get nil. But if I do set foo and I set an EX of 5, which is the same thing, and I do TTL of foo again, you'll see it has 2 seconds left. And then when it gets down to 0, it's going to expire and it's not going to have anything left.
Got it. So -2 is just the standard it is expired flag.
Well, -2 just means it's gone. It doesn't exist.
Okay. Right.
So if I did a TTL of nothing, it comes back with -2. When it reaches 0, that means that it's essentially expired. I think you still might be able to get it, but it's almost expired. But yeah, those are strings. So like those are the most basic of data structures.
Right.
the other another neat one that a lot of people use, and these are like essentially dictionaries or hashes. So I can do a hash set person one, and I could say name Steve, age 34, hair color black, and I could get anything in this hash by just using the field name. So if I just want to pull back name or age, I can do that. I can do an HM get person code one and get the age and name, and it'll bring both of those back for me, right? So like this is now like a dictionary that exists in Redis that I can pull back. So let me, and if I want to get everything, I can do an age get all person colon one, and I can get everything, and then I'll bring back. You know, it's funny because I'm actually looking at this. I'm reading my screen off of the share and not the actual stuff. So I'm going to look over here now, and you can see that this actually allows you to build like almost something that kind of resembles like a document that you can store an object in, and potentially like create indexes around and query, right? Like you kind of get that sense. But let's just delete person colon one now, and now it's gone. There's also sets. So if I do a sad, which is the loneliest of Redis commands, which stands for set add, and I add apple, banana, and orange. I can check to see if a particular item has been added to my set yet. So I can do s is member fruit kiwi. It's not, or orange, and it is. I can get all the members of a set, apple, orange, banana, and if I try to add to that set again, apple, you're going to see that it's not going to add it. So like nothing was added to it. So the 0 just means that nothing was added to the set. And so like this is another data structure that's often used for things like indexing or keeping track of a bunch of keys that you might want to delete at some point. So like that's actually a really common use case is that, oh, I have all of these keys that I'm going to want to delete eventually. So let me store them all in here. And when it's time, I just enumerate this set and just go through and delete all the keys, stuff like that.
Okay. We got one quick question.
Sure.
From this one's coming in from Twitch, and this person was asking, can you only get keys of person one? And I guess that question was more so, okay, hey, you created this hash, right? You added all these keys to the hash. But that person one is just a convention, right? Like it is just the name of the key. You could name the person two. You could not even put the number there, right? And it would have just worked the same way. Is that correct?
Yeah. So the trick is that like everything, the keys are just binary safe strings. So like anything that's a string, you can use as a key name in Redis as long as it's under 512 megabytes. I've never seen anybody use a 512 megabyte key, but if you want to, you can. It's allowed. You can do it. But they're just the key names, and that key is pointing to a data structure. So if I do a type of person colon one, you can see that it actually pulls back the data structure type, which is a hash. If I do a type of fruit, you see that it pulls back a set. So like if I wanted to do like an hget fruit name, you're going to see that I'm going to get a wrong type operation here. So this is telling me, oh yeah, this type doesn't make any sense. What are you doing? You're trying to do an hget on this set. That doesn't make any sense to me. So like all of this data is bound to different data structures, and all a key represents is a different data structure in Redis, or I mean nil if there's nothing that exists at that key, and then you can perform all the operations that you want on that key. Yeah, so like the reason I do person colon one is the normal naming convention for keys in Redis is you're namespacing things based off of colons.
Okay.
So like another way to store information about person colon one would be say set person colon one colon name Steve. Set person colon one colon age 34. Set person colon one colon hair color black. and I can get all of those different keys, and those are all something in Redis. But because hashes exist, you would not do this, right? But that's my point, is that this is a normal way you would separate different namespace or keys and create something more sensible out of them. Now, what will often happen is, say I want to preserve all of the people who are named Steve, right? So say I want to be able to find all of those documents that I have, that all of those hashes that I have that have the name Steve. So I'll do another one. Each set person : 2, name Steve, last name, jobs, age. I think he was like 56 when he died. Hair color. I think he was bald. Right. And what I would then do, I would have a separate set. So again, I'm going to use the loneliest of Redis commands, and I'll say person : name : Steve. So people named Steve, and then I can add person 1 and person 2. So let me do that again. Sad person : name : Steve, person : 2. And then I would get all of those. If I wanted to find all the people named Steve, what I can then do is I can do S members, person : name : Steve. And then I would just do an each get all, person : 1. Each. Oh, I misspelled each get all. See, this is why you shouldn't do anything in the command line, but each get all.
Command line, all the things.
And each get all. And like this is like the way that people used to build indexes in Redis, is like, oh, I would have these hashes that would have my actual documents in them, or I would have these strings that have a JSON blob in them, and I would just query them. Mm-hmm. And that's the way that people used to just build indexes in Redis. And I say used to for a very good reason, because we have evolved since there in the last few years. And we could talk about that if you want, or whenever you want. But that's actually where stuff gets really neat.
But it's kind of interesting though, because what I'm seeing now is that you're using multiple data structures together to kind of do something, right? So it's not just here's a hash and here's a set, but here's I have like these hashes, and now you're indexing them in sets, right? And I'm like, that I can see how that can make a very performant lookup, right? Because now you just call it memory, right? So you just have a bunch of sets with these different with these namespace conventions, right, to help you find stuff.
Mm-hmm. It's super performant. There's one problem though.
Tell me.
It's actually a very big problem. It's very difficult to distribute. Very difficult to distribute. So this kind of indexing is excellent for performance. It's very hard to keep consistent and distributed. And the reason for that is the way that Redis separates the key space in a clustered environment. Redis basically takes all of your key names and it hashes them to build a hash, and then it mods that hash by like 16,530 something. Don't quote me on that exact number, but it's something like that.
It's a magic number that it hashes it by.
And that's the number of slots that are available in Redis. And each shard in a distributed Redis system is responsible for a range of these slots. Yeah. So you might have the index on one shard and the document on another shard, or like parts of the index on different shards. Yeah. So that's actually why the other thing I was telling you about before, which is the querying and indexing capabilities of Redis that we built, are super useful, because that makes actually all of this kind of moot and not very and look kind of bad by comparison to like what we can do now. That's actually where things get really fun. And if you want to learn about that, I'm going to insist on dropping into .NET and actually doing stuff in .NET instead of in the command line, because that's.
Well, let me do that. Let's head over to .NET.
Do it.
All right. So the first thing
I'm do that. I'm sorry, I didn't mean to cut you off. But like while you do that, we did have a question. This one is coming also from LinkedIn. Reese's asking, what is the limitation for the size of the value? So I think this is when earlier you were talking about the size of the key. Could be super big.
512 megabyte key. That man. I'm going to try and fill that just because.
The key name can be up to 512 megabytes. and the values can also be up to 512 megabytes.
Okay.
So that's on both the key and the value.
Okay.
Is that 512 megabyte limitation? There is some historical reasons for that. Salvatore, who's the creator of Redis, he had some opinions as to how we might be able to mitigate that. But as far as I know right now, the limit is 512 megabytes. If you have more than 512 megabytes that you need to store in a key on Redis, I have other questions for you. You could maybe you want to store a whole Blu-ray video.
Maybe
if you want to pay us to store whole Blu-ray videos in Redis, please, by all means. But
give me your money.
Options to turn the money someone one day, but it would be a weird use case to have something larger than that. But yeah, you can go up to 512 megs for what you can store in a single key in Redis, and also what the key name can be in Redis. Cool. All right. So actually, the first thing I'm going to do is I'm going to kill this Docker image. I will clear this out, and we have another Docker image called Redis Stack, which is sort of becoming like the preferred way to download Redis and to run Redis. And you could do a Docker run -b -d-p 6379:6379 Redis. Oh, and also I'll do a -p 8001 Redis /Redis stack. And what that will run for you is this other Redis instance that actually has these things called modules enabled. So if I do a module, again, I'm on the wrong screen. If I do a module list, you'll see that I have these modules here. So like REJSON, time series, search, BF, which is Bloom filters, or Redis Bloom. And the other neat thing is our GUI is actually written into this. So if I go into, I know I'm on the wrong screen now. I'll bring it
Redis Insights, or
yes, yes, it is. So the GUI for Redis is Redis Insight that we prefer people use, and that actually allows you to see your whole Redis database for this local instance. For this local instance that you're running live, and you can actually see what's in there. So I'm just calling that out. But anyway, let me go in and
this Redis stack thing you just showed us, it is the same with extra stuff, right? Like it's not like a version. It just has extra add-ons to it.
Yeah. So like the Redis modules are fulfillers of this thing called the Redis module API, which was added to Redis and Redis 5, that allows you to build essentially extensions of Redis. And it allows anybody in the community to build them. And we have built a few that we use very often with our customers. And the licensing on them is quite permissive. I'm not a lawyer, so don't take any legal advice from me. But essentially what it is if you're using this, please don't compete with us. Don't build another database product that's going to compete with us. And so basically, like, the impetus behind this is so a lot like AWS and Google and Microsoft can't just build things that use these products to compete with us. That's the whole impetus behind it. But other than that, it's free to use. So what I like to say is, please don't compete against us. And if you want to pay someone, to manage your Redis instances that have these, you have to pay Redis. I mean, I think it's a pretty fair deal, but that's all a matter of opinion. But anyway, so I'm going to just do a .NET new. Can I zoom this in? Yeah. All right. So I'm going to do a .NET new. I'll just write console out. Console. Let's call it. What's this? I forgot. What's this live stream called again? .NET Live or something like that?
.NET.
Inside.NET.
There you go.
Call me out if I misspell it. I think I spelled it right.
No, you're good.
Inside. And I'm going to do a .NET. If you hear a baby screaming in the background, it's my son. He's being put down for a snap, and he's very mad about it.
No worries at all. I can tell you plenty of stories where my son has walked in on streams.
My son's 2, and sounds like he's very upset about going down for his snap today. So I'm going to do .NET add Redis ohm, and so Redis ohm is a library that I built that essentially allows you to use link with .NET to build indexes in .NET and query things in Redis.
Ooh.
So we're gonna look at that.
Ohm is like the object model, which I'm guessing is kind of like or object mappers. It's like entity framework for Redis. Is that a fair comparison?
That's sort of the idea. OM stands for object mapping, and more. We don't call ourselves an ORM because there's no relations in Redis.
No relations, right?
But and we like to be technically correct, which is of course the best kind of correct. So let me pop up in Router real quick. I'm looking at. Open. I'm just going to consume this window. So let me go ahead and open up the project file in here, and let's just go off of the same model that we were working with before. Public class person, and I'm gonna mark person as a document, and I'll just say that the prefix is equals person. Now, in here, I'll just add some properties. I'll add a prop string name. Now let's do first name. And then I'll do a prop string. You know, it's so funny. I'm so used to using my Mac that me on my Windows machine is. I'm feeling like a little slow right now.
That's good.
And I'll do a prop string hair color. Now, if I want to say that any of these are indexed, and I'll also do a prop string ID. Now, first off, the ID I'm gonna set as my Redis ID field, and that's gonna pin the keys ID, the keys unique ID to that field in Redis.
Okay.
And then I'm going to go ahead and I'm going to mark all of these other fields as indexed.
Okay.
Interesting.
And now all of these, when I create this index in Redis, are going to be indexed, and I'm going to be able to search for the. I'm going to be able to search the index for different documents that hold these things based off of these values.
Right.
So like this actually does all of that other modeling work for you. So I'm going to create a provider equals new Redis connection provider, and I'll pass in this URL.
Okay.
And that's the URI is just a Redis URI. Redis is the scheme. Redis S is also supported, and then I have the host name : password. And if I wanted to have like a username and host name : port. If I wanted to have a username and password, I would just say username : password at localhost : 6379. Just like most URI based things work. Now, if I want to create this index, all I have to do is do provider.connection.create index type of person. Now that index is created, and so anything that I insert to Redis that has this person as its prefix is going to be indexed as one of these people. Oh, and the other thing I'm going to do in here is I'm going to actually have the storage type be JSON. So storage type equals JSON, and that it's going to save this object into Redis as a JSON object. So let's go ahead and say I have this thing called the collection, which is actually the queryable interface that allows you to query things in this. So var people equals provider.redis collection person. And now that strongly typed connection, I can actually start inserting things into and querying things from. So I'm going to do people.insert new person. Let's do first name equals Steve. Last name equals Lorello. age equals 34, hair color equals black. And let's do let's do a couple of other people too. I like to use the Muppets, but that's just me.
Muppets are good.
And I've never gotten sued before. I've never gotten sued for it before, so I'll do it. Kermit.
Yeah, you're definitely not going to get sued because of this show.
Frog, and I think he's like 70 something.
At least.
He has to be.
He's not young. He's green. He's green. His hair color is he's actually an amphibian, so he doesn't have any hair color. So it might be
right
in here. Let's do Beaker. Bunsen. Oh no, wait. Bunsen is the other one. What's Beaker's last name? I forget.
I don't know. I don't think he has one. What's Bunsen? It's funny. We were just going over this the other day.
Hold on. Let's see. Let's ask ChatGPT.
ChatGPT knows all things.
The ChatGPT. Let's ask the new great oracle.
Yeah, Bunsen's last name is Honeydew.
Yep,
but I don't.
Well, I mean, I could Google this a lot faster, but it's more entertaining and topical.
Way more entertaining to use ChatGPT because it'll tell you a story that you didn't know.
What is Beaker the Muppets' last name? Does not have a confirmed last name. Though Beaker is typically referred to simply as Beaker, and Muppets often have a unique and distinctive personalities and are not always given local names. Okay, can you please? I'm going to ask ChatGPT what it does best. Imagine things. Come up with a topical last name for Beaker.
Oh, you broke it. Now
I'm sorry, we're off on a tangent here, but this is just too much fun. I couldn't not do it.
ChatGPT is officially broken.
Oh no, I broke out ChatGPT.
That's funny.
Okay.
I love it. That's hilarious.
Well, anyway, I can fill in the rest of this. So Beaker's hair is orange. Bunsen's hair is bald.
Yeah, he's bald.
Bunsen, I think, is like 65, it's like 60 or something like that, and Beaker's like 55, I think.
There you
go. So I'm by far the youngest person here. I'm by far the youngest of the people here. Let's see. Did ChatGPT figure it out yet? Currently, how about Bunsen? All right, fine. That's going to get a little strange, but we'll call it Bunsen.
Bunsen, honey. Yeah, whatever.
Sure. We're going to go with it. Why not? So anyway, I'm inserting all of these people into Redis right now. Right. So I'm now inserting them all. Bro, I should get GPT plus. That's not a bad idea. I realistically, this is a Microsoft Technologies based podcast, so I should just use Bing, right? I should just pull up my Edge browser and use Bing. That's really what I should have done. That was obviously the move right there.
What's really annoying is I use Bing on a regular. I use Bing, but I use Chrome, and then when I use Bing and Chrome, it says, "Oh, sign up now for access to the AI stuff." I'm like, I already have it. You just refuse to let it work in Chrome. What is up with that?
It's not actually. I'm not 100% sure, but I'm almost positive it's not actually built into the Bing app.
Oh, really?
Or the Edge app.
Oh, you feel like it's
I know. I'm saying I'm pretty sure it's not actually built into the Edge app.
Right. Huh.
They just refuse to let anybody who's not using that Edge
browser.
Edge browser to access their Bing technologies, and I think that's a pretty smart play on their part. And it's their app. They can do whatever they want with it, I guess.
Yeah. They paid for it. They paid a lot of money for it. So I get it.
They paid a lot of money to port Chromium, which is an open source project, to Edge so that they can do this.
Yep, pretty much.
Anyway, we're way up. We're like dramatically off topic here. But anyway, so I've inserted all these people into Redis. So what I can do now is I can actually query them. So if I wanted to find all of the people whose first name is Steve, I can do a for each person in people queer p.name first name equals Steve. I can do that, I don't know why I'm putting a semicolon at the end of there. And I can say person dot ID. First name is and if I just ran this, I'm going to do two things. And of course, I'm producing this all live, so this is, of course, I'm sure something's getting wrong, but that's fine. I'm going to do a monitor in here, which is actually going to run and show you everything that's being run against Redis. And I'm going to go back into here and do a .NET run.
You didn't even build it first. You're way better than me.
Yeah, and so you'll see actually what's going on behind the scenes here. So it goes and creates this index, and now this index is being created called person -idx. It's being created on JSON documents. It has one prefix, which is person, and it has a schema. So the schema is basically what's being indexed by Redis. So first name is being indexed. So $.first name. So the JSON path $.first name is being indexed as first name. It has a tag. It's a tag. It has a separator in it. Same thing with last name. Age is being indexed as a numeric. Hair color is being indexed as, again, a tag, which is like an exact match string. And then it's adding all of these JSON objects to Redis. So that all of those objects I was creating, it's adding into Redis. And it's automatically generating this ID, which is a ULID, which is sort of like a UUID, but they're sequenceable. So you can actually see, like, relative to other ULIDs, like when in time this was created. You can replace this with a UUID, that's fine too, but by default we use ULIDs. And you can see that this person object is being created with that ID, first name, last name, age, hair color, all that stuff, right?
Interesting.
And then when I actually want to search for it, I just do an ft.search, all the people whose first name is Steve. And if I X out of here, and I went back to Redis CLI, and I did a clear, and I did an ft.search person IDX, and I did a star, you can see that it'll actually pull back all the people for me, right? All the people, 3 of which are Muppets. And if I did a star and I did a ages 55 to 65. Oh. And this is why I should use Redis Home. But yeah, it'll actually allow you to filter down different things within this. And this is a hell of a lot easier to do than going through and creating a bunch of sets and trying to keep them all up to date with each other, right? Mm-hmm. This makes a lot more sense than that. And the beauty of this is that unlike those other cases that we were talking about with indexing documents in Redis, the index is all preserved on a single shard. So all of the documents are preserved on the same shard that their index is on, and the index is built on that shard. And so, like, when you query these things or you update them, importantly, there's no worry about, like, oh, I have to go through all these sets and update things. I don't have to do any of that. It's just there. And the nice thing about JSON now is that, unlike before, where, like, I'm just assuming this, but you guys have probably used Redis before, and you've probably taken a JSON blob and shoved it into a string in Redis. Am I assuming?
Maybe.
You might have done that.
Maybe. It's possible.
Cecil looks guilty. He's like, yeah, I've done that.
No, it's happened.
Okay. But what the cool thing is with these, I'm pointing at the wrong screen. With these, what you can do, so these keys now are, they're JSON strings. So if I do a JSON.get and I drop that string in there and I just drop the base path, okay, great. I got this key, this whole key back, which is just a JSON object. But what I can also do is I can do first name.
Oh, and you can use, like, the JSON syntax to kind of, like, dive into the objects and pull out the values.
Yeah, exactly. And it allows you to resolve, like, all the standard JSON paths and all the standard JSON paths. Like there's some functions that exist in JSON path that we don't support, but like for the most part, like anything that's in a standardized JSON path will support. Will support you doing. And when you're creating indexes, like we allow you to index based off of JSON paths, so you can path down to like whatever the thing is in that object that you want to index and index based on that.
So I know we lightly kind of mentioned this before you switched over to the .NET code, but like the data structure you're using now, is it just called JSON, or is it like a JSON set? Like what exactly is the data structure you're using to do this?
So I'm using one data structure and one thing that's not technically a data structure. So I'm using a JSON data structure, which is what's actually preserving the data for me. And I'm using a Redis index. In that Redis index, I say it's not really a data structure because unlike most data structures, it doesn't actually live in the key space. So like you can't go and like delete a particular item out of that index. You have to blast out the entire index or delete the whole object, right?
Yeah.
Like those are your two options. So it doesn't actually exist in the key space, but it says index that's created and maintained the secondary index on top of your documents that allows you to query it. So I'm using these two things in conjunction. And the nice thing is it's totally invisible to you because you're using a nice high-level library to access it.
Yeah, because I saw as the logs were going by, there was like an ft.json, and then you're doing the searches. And I was like, yeah, those don't look like the commands he showed us earlier. So there must be a different data structure that's taking place here.
So FT, I think FT actually stands for full text, which is that's a whole nother story because you can do full text search with this too. But like FT stands for full text, which is the origins of a module that we created called Redis Search, which was originally Redis Search Index, which we adapted to be more of like a proper querying engine for Redis. And then JSON is from the Redis JSON module, which allows you to create these JSON objects in Redis and query them via their JSON path. And by merging these two things together, you have these documents, which are JSON documents, which you can now query using Redis, which is super nice and super useful. The only real limitation here is that like you can't query and update at the same time without using a script. So if you wanted to like find all the people named Steve and change and increment all of their ages by 1, you would need to write a Lua script to go in and pull out all those keys and then go into the key and update the ages. Right. That's the only way you can do that in a totally isolated fashion. You can just update all the Steves to have their names be or ages be 1 greater. It just wouldn't be isolated unless you use the script. So that's the one big downside.
Yeah.
Okay. Which like it's a limitation you have to be aware of if you're trying to use this if you're using this as a document database. But it's depending on your use case. It's not necessarily a terrible limitation.
It's not. I mean, it for bulk actions you have to deal with like reads and writes differently, but that's not the end of the world. Specifically, when you're doing document stuff, like you shouldn't really be doing things across many documents.
Yeah.
Anyway. So.
Yeah. And another cool thing about Redis Home is that like if I wanted to update Steve's age, so if I wanted to say person : age. So if I want to increment it, then I can go into people and then save it.
Oh, and that's directly from the collection. So you legitimately are just mutating a collection in memory, and then you save out the mutate. Oh, that's nice.
Yeah, and if I do an ft.search person.
You gotta type in the search too.
I think that's I was about to say.
I'm sorry that this part is so painful. Oh, you are totally right. I could find all the people whose ages are now 35, and what it did was it actually, you know what it's going to keep adding things on because of the way I'm inserting these things, but I'm just going to do it one more time so you can see it. And there's going to be 3 Steves now. That's fine. But what it's actually doing is it's creating a diff of all of the it's basically it's preserving the state of your of the documents that are queried out, and it's creating a diff between that and like what the current setting of that is, and then it's building that diff and then saving it to Redis. And the alternative is you can just turn all of that stuff off, and it just basically do a put and put the document back and overwrite the old document. You can turn all of that off if you want to, but this is usually more efficient because you're not sending as much data if you're working with very large documents.
Right.
That makes sense.
But yeah, so like that's like how you can do document stuff with Redis in .NET. It's pretty. I like to think it's pretty easy. We have a decent community of folks that contribute and work with Redis Home that, I'm pretty active, and I'm pretty active there. And I think I just released a new version of it last week or something. So, yeah. So this is all live development. Let's see other cool use cases of Redis. Another really neat one. How much time do you guys have?
We can do another like 5 minutes or so.
Okay.
We can burn through it.
Yeah, sure. So like another really neat thing that exists, and this is another course that's coming out, is the probabilistic data structures course in Redis University. We have these things called probabilistic data structures that allow you to like answer questions that like would ordinarily take a lot of memory without using a lot of memory. So like, let's say you have a billion users or something like that, or a billion users, and you want to have, and you want to see like, has this user been here before, right? Or, well, actually, no, that's a bad example. Say you have like a list of malicious websites that you want to keep, a list of malicious URLs you want to keep, and like, you don't want to necessarily preserve all those URLs because that's kind of expensive to keep to maintain a whole list of all of those, at least in memory. We have this thing called a Bloom filter, which allows you to basically create a set of things that have been seen already in a super compact and memory efficient way. So bf.add. So I want to say malicious. And this, by the way, this is its own this is like a huge topic in its own talk and everything. I actually have a talk that I give on this. If I want to say malicious URL, and I can say add URL. What this will do is it'll actually create this Bloom filter for you, which is like sort of like a set, and it sort of operates like a set, but instead of having to maintain all of the records, you maintain like a tiny fraction of the size of those records, and you're able to still like pretty closely answer the question. Sorry, I forgot to turn do not disturb on. That was my boss telling me to use my Grubhub money by the end of the month. Sorry about that. Well, we have a program where like they give us like credit for Grubhub at work, but like essentially like these Bloom filters, and there's a couple of other data structures that I guess I don't really have time to go through, but they're really cool. Check it out. Yeah, this has really been a poor explanation of this, but sorry, I ran out of time. But like, so these probabilistic data structures do this thing where they'll have like a question that you want to answer. So like your question might be like, what's the cardinality of the set, or have I encountered this thing before, or what quantile in is this particular instance in, and like these might be things that you operate on enormous sets, like so billions or tens of billions of records that you might be working with. Like you might have a set of 10 billion or a million malicious URLs that you want to check against. And what that would ordinarily mean, if you wanted to preserve all of those, you would need to preserve them all in a set, just to guarantee that, oh, I know that this is, I know that I definitively am looking at a bad URL, right? But what you can do with these Bloom filters is you can say, all right, have I seen this URL before? And it will definitively not give you a false negative. So like it'll tell you like, yeah, you definitely probably have seen this before. Or it'll tell you, no, you've definitely not seen this before, right? Mm-hmm. But it might tell you it's like, you've seen this before, but it might be lying to you. Right. There's a relatively small chance that like a 1% chance or something that if it gives you a positive, it's a false positive. and it'll do it in a way that is super compact. Like, so you might have 1 million records, and say each URL is 100 bytes or something like that. That's 100 million bytes. So that said, it's 100 megabytes of data. And realistically, like we're talking, usually scales much larger than this. So that 100 megabytes of data, you might be able to condense down into like a couple of kilobytes. Yeah, and it works really well. And that's like we have Bloom filters, Cuckoo filters for that.
That's great.
We have hyperlog logs in Redis that allow you to measure cardinalities, and that's not in the Redis Bloom, which is that extra module I was telling you about. And we have T-digest, which allow you to basically take a look at numeric ranges and check out what quantile something exists in within that numeric range. Again, and all of these are like these probabilistic data structures, which are very specialized class of data structure, which allows you to compact these things down really tinily, like really smallly.
But like you said, these are all in base Redis, right? Like this is not extra stuff that you're talking about. Is this just all?
So the Bloom stuff. So Bloom filters, T-digests, and Cuckoo filters, and Countmin sketches are in Redis Bloom, which is also available in Redis Stack. Okay. Hyperlog logs are available in the base Redis. They're available in like every instance of Redis. It's like Redis 2 or something has had them. But yeah, that's like a data. These probabilistic data structures are something that like we're kind of passionate about because we're a bunch of data structure nerds who like to make very compact and very efficient memory because we're a memory first database. But yeah, they're very compact. They're very fast. And yeah, they're used all over the place for all sorts of different applications where you might be encountering billions of records, but you don't want to have to maintain all of that.
Yeah. Okay. Yeah. Steve, I feel like we're gonna have to have you come back and talk about all the other stuff that you didn't get a chance to talk about because I feel like so much. Again, like, there's so much more in Redis that I know what I didn't know, but now I know even more that I didn't know. so we might have to have you come back and have you talk about some of these other things, as well as kind of diving into like some more specific use cases. So maybe if folks want to do that, if you're down for doing that, like we'd happily have you come back.
Yeah, man. This is a lot of fun. I mean, like when I was like I was towards the end of like how I didn't really want to do developer relations anymore, but I saw the .NET role at Redis come up. I'm like, I can do that for Redis again. Definitely do that for Redis. Okay. And it's like I'm super passionate about Redis. Love it. It's great. Yes. Great product. It's a lot of fun to work with. There's so much you can do with it. It's such a rich and exciting area that so much is happening in all the time. Nice. Yeah. Thanks for having me on, though. It's great.
For sure. And then real quick, so for folks who want to reach out to you, I guess they could just hit you up at Lorello on Twitter, right? Yep. I'm guessing you're on LinkedIn and Mastodon and Blue Sky and like all the other.
I'm on Blue Sky, but I actually I'm not a Mastodon yet. I should be, but I'm not. I just haven't gotten around to setting it up.
I haven't either.
No.
Yeah.
It's just so many of them, dude. Like it's just like, where do I find them? Everywhere. Like
another great resource for like if you want to talk Redis with me, another great place to find us is Discord. We run our own Discord server. I think it's discord.gg/Redis. Just search for Redis Discord and you'll find us. Or ask ChatGPT; it'll probably know. But yeah, find us on Discord. Like I'm there all the time. I have a bunch of colleagues that are there all the time. And we have a really vibrant community. I think we have over 10,000 people.
Oh wow!
Like probably more than 100 of them are active every week on Discord. It's a really vibrant community. There's a lot going on in Redis, and
nice.
We're kind of all there to help out and chat. And I'm the .NET person there, so like .NET questions usually come to me. But yeah, stop by Discord, find me on Twitter, find me on LinkedIn, find me wherever. I'm all over the place. Happy to help.
Nice.
All right, man. Well, hey, again, appreciate it, Steve. Thank you so much for coming on, and thank all of you for watching. Again, we're usually here on Wednesdays talking about all things .NET. If you like the episode, do the YouTube thing and hit the like button and leave us a comment. If you'd like Steve to come back, let us know too. I know we can try and figure that out on the schedule. But until then, thank you all again so much, and we'll see you again on Inside.net. Bye, everyone.
Bye.